All right, welcome back, everyone. Today we're going to talk about graphing linear equations. So in this section, you're going to learn the definition of a linear equation with two variables and how to graph linear equations using a table of points. So a linear equation in two variables is given by ax plus by is equal to c. When a linear equation is graphed, the result's a straight line. Now, it only takes 2 points to make a line. So to graph these lines, simply determine 2 points that are solutions. And in general, the best way to do this is to choose an x value and just solve for y. And so let's practice this. Here we have the linear equation 2x plus y is equal to 5. Now we only need 2 points to make a line. So what we're going to do is just choose some x values, solve for y, and that'll give us points that are solutions. So let's start off with the easiest one. And we'll let x be equal to 0. Now if x is 0, we get 2 times 0 plus y is equal to 5. Well, 2 times 0 is 0. We get y equals 5. And so our first point is 0 and 5. Remember, it's always x comma y. Now we need a second point. And although 0 is usually the easiest one to start with, the next one's somewhat up to you. But I would suggest to use 1. And so let's let x be equal to 1. Now we get 2 times 1 plus y is equal to 5. Well, 2 times 1 is 2. If we subtract 2 from both sides, you get y equals 3. And so our next point is 1 and 3. X equals 1, y equals 3. And we only need 2 points to graph this line. So we have the point 0 and 5, and then 1 and 3. And so we have our 2 points, and now we can just draw a line between them. Let's try another example. Here we have the equation negative 5x plus 3y is equal to 15. So let's start off with the easiest one, x equals 0. In that case, we get negative 5 times 0 plus 3y equals 15. Well, that goes away because it's just 0. So we have 3y equals 15. We can then divide by 3, and you get y equals 5. And so again, our first point is 0 and 5. So let's try using x equals 1 again, but it's going to cause us a problem. Negative 5 times 1 is negative 5, plus 3y is equal to 15. You can add 5 to both sides. And so 3y is equal to 20. Divide by 3, and we get y equals 20 over 3. Now that's a perfectly valid answer. The problem is it's kind of tough to graph. So we need another number that's going to work out easier, or at least another number that's going to give us a whole number, something easy to graph. So if you're not sure which number to use, let x, and if you run into this problem where you wind up with a fraction at the end that's hard to graph, let x be equal to the coefficient of y. So what I mean by that is we're going to now, instead of using x equals 1, we're going to use x equals 3. And so if we let x equal 3, you then get negative 5 times 3 plus 3y is equal to 15. Well, negative 5 times 3 is negative 15. Add 15 to both sides. You get 3y is equal to 30. Divide by 3, and so y is equal to 10. And so our second point is the point 3 and 10. Now again, we run into a little trouble with this graph because it's a little too small. But there's no reason we can't fix that. And so if we just trade out the graph and just make the points a little different. Now we've got the point 0 and 5 and the point 3 and 10. And when we graph our line, there we have it. Let's try this again. We're going to graph the equation y equals 3x. So here again, we can let x be equal to 0, and we get y equals 3 times 0, which is just 0. And so our first point is 0, 0. We can then let x be equal to 1. We get y equals 3 times 1, which is 3. And so the next point is 1 and 3. And so we have 0, 0, and 1 and 3. And if we draw a line, this is what we get. Let's try another one. Here we want to graph the equations x equals 4 and y equals negative 2. Now there's something to be said about these particular equations. X equals 4 just means that it doesn't matter what y is, x is always equal to 4. So we can choose y to be anything. 4 and 1, 4 and 2, so long as x is equal to 4. Well, if we plot those 2 points, 4 and 1, and 4 and 2, right, or 4 and 3, you can see that what you get is a vertical line through x equals 4. Similarly, for y equals negative 2, it doesn't matter what x is. Y is always negative 2. And so we get the point 0 and negative 2, 1 and negative 2, 2 and negative 2. It doesn't matter. Y is always negative 2. And so what you get is a horizontal line you get a horizontal line through y equals negative 2. Horizontal and vertical lines are very important, and you will see more of these throughout your algebra courses in the future. Finally, we want to graph this linear equation. And so we have y equals negative 1/3 x plus 2. Again, we can start with x equals 0. That's usually the easiest one to start with. And so we get y equals negative 1/3 times 0 plus 2. Well, negative 1/3 times 0 is just 0. And we get y equals 2. And so our first point is 0 and 2. Now we could try x equals 1, but we're going to run into the same problem where we're going to wind up with a fraction that we can't necessarily graph. When you have a fraction in front of x, like we do here, then start off by choosing x equals 0 and solve it just like we just did. But for your second point, for your second x value that you choose, use the denominator of the fraction. So again, we're going to let x be equal to 3. If we have x equals 3, we get y equals negative 1/3 times 3 plus 2. Well, negative 1/3 times 3 is just negative 1 plus 2, which is 1. And so our second point is 3 and 1. By using the denominator of the fraction, we've pretty much guaranteed that the y value will be a whole number. And so now we have the point 0 and 2. And the point 3 and 1. And we can just draw a line between them. So at the end of this lesson, you should be able to graph a linear equation with two variables.